The Indian Space Research Organization started 2024 with a bang. On the very first day of the year, ISRO achieved a significant milestone with the successful launch of India's first X-ray polarimeter satellite, also known as XPOSat. On January 6th, ISRO placed the Aditya L1 spacecraft in a halo orbit around the Lagrangian point. Aditya L1 is India's first solar mission, which was launched on September 2, 2023. The L1 point is located roughly 1.5 million km from Earth and enables the spacecraft to view the Sun continuously. Now, what does this mean? What is the mission of Aditya L1? And why is this point necessary? Let us understand this and much more in today's conversation with Girish Linganna. Girish Linganna is the director at ADD Engineering Components India Private Limited, a subsidiary of ADD Engineering GmbH, Germany. Renowned as a highly respected defense and aerospace analyst, he has gained international recognition and national esteem for his expertise. His contributions to the aerospace and defense field have been featured in over 20 reputable international media outlets, along with numerous others that acknowledge his profound knowledge in the domain. Can you explain us that now that Aditya L1 has been placed into the orbit, what is it going to do that, and what will be the result of its placement over there?
See, now Aditya L1, which began its journey on September 2nd, it took almost 127 days to reach the Lagrange L1 point. The reaching of Lagrange L1 point means we have shifted the satellite from the highway. You can say it was moving in the national highway with a very high speed. Now we have shifted to Lagrange L1 point, means it is been shifted to a service road. Now it has been shifted and it has been parked at a point called as the Lagrange point. That is the Lagrange L1 point. See, these points are called as the sweet points, means where the parking will be very easy, means there won't be gravitational pull either by the sun or either by the earth, and it will be a somewhat, you can say, the effect is nullified. The centrifugal or centripetal force or the gravitational force between the two bodies, means pulling the satellite on the either side, that will be nullified. So it doesn't mean that it will be standing steadily on the Lagrange L1 point, but it will be moving around the orbit called as a halo orbit. That is, the shape is very irregular shape. The halo orbit is something like a complex shape, but it is perpendicular orbit towards what Earth is moving around the sun. Earth moves around the sun from east to west, you all know that. But this halo orbit is such an orbit that it's perpendicular to north and east, means east and west orbit. Means it will be like the satellite will be moving from north to south. So it is a perpendicular orbit and it is an halo orbit. And it for one complete rotation around the halo orbit, it takes 177 days. So such big is the orbit. I can tell you in kilometers also, but it won't make sense to remember also. But it takes 177 days to complete one rotation around one revolution around the orbit. Means if the Earth wants to revolute around the sun, it takes 365 days. Okay, that completes 1 year. So here it takes 177.65 days. So to complete 1 year, you can say. So that is the halo orbit. Since it is what you can say is revoluting perpendicularly between the Earth and the sun, there won't be any eclipse or anything which can come in between these two and stop this satellite observing the sun.
So it doesn't.
So no eclipse, no body or anything will come in between these two to stop the satellite observing the sun. So this Aditya L1 is nothing but a satellite with lot of telescopes, which is observing the sun and studying the sun. Now you can say why you cannot study the sun from the earth, why we have spent 400 crores to send to 127 days, sending to L1 halo orbit and start studying the sun. Why not you study from the ground itself? Because you can see the sun. Why didn't you see the sun from the ground and study it? Many people will question. So see, when you want to study the sun from Bangalore, you are studying the sun. How much time you can study? Maximum 12 hours sun will be available to you. Then next morning only you should wait for the sun to study. So you might see today, yes, morning is here. Next, we will get night, but America will have morning. Why can't you continue studying from America? Then why can't you come to Australia and study when there is bright? Then why can't you go to some other country and study when there is sunlight? You can have many ground stations and do continuous recording of the sun, no doubt, and then combine the data. But it won't be a very accurate data. When you get so many data from so many ground stations and collecting the data, it won't be very accurate. And also see, when the sunlight reaches the ground, it has to come through the atmosphere, sun's atmosphere. Sun also has an electromagnetic field around its in atmosphere, because magnetic field is created about our in atmosphere also, because in atmosphere we have molten iron and nickel and such substance. When our earth rotates now, it tends to generate a current and thereby magnetic field. So we have a magnetic field also above us. So these magnetic field and atmosphere will cause disturbances of the radiations or sunlight or whatever comes to the earth. So you cannot get a very accurate data. That is why we decided to send Aditya L1 to Lagrange point and study the sun from there. Okay, this is the first point. Second point is the distance between the earth and the sun is 15 crore kilometers. So 15 crore kilometers or 150 million kilometers. So 1 million is nothing but 10 lakhs. So 150 million kilometers. So I am telling you, for us to understand more easily, it is 15 crore kilometers. We have sent our satellite at a distance of 1.5 million kilometers, means 15 lakh kilometers. So 15 crore and 15 lakh you just see, means it's only 1% of the distance we have gone from Earth to Lagrange point. Still there is 99% distance. From Lagrange point, we are studying the sun, because there is no disturbance in between, because it moves in a perpendicular to our Earth rotation orbit, and we can have a continuous view. That is the intention of sending Aditya L1.
Also, sir, what will, once we get the data, what are we going to find out? Like, what would be the result of those data? What can we find out after that?
See, I will explain you how the sun is. So what will happen is, you will understand what we are trying to study easily. Okay, I will just share a screen to you. Image is there, no? See, sun has totally 6 layers, 7 layers, I can say. 7 layers is this sun. The first is the inner core. The inner core is where the lot of nuclear fusions happen and heat is generated. So heat is generated in the center core of the sun. So what is the heat generated? If you ask me, it will be somewhere around 15 million degrees centigrade. What is that? 15 million degrees centigrade. So that is 15 crore degrees centigrade is what is the heat generated in the center of the sun. There are 4 inner layers in the sun. That is the convection zone, radiative zone, inner core, and there is one more small layer will come. But we are not worried about the inner layers of the sun. We only study the outer layers of the sun. There are 3 outer layers of the sun. One is the photosphere, next is the chromosphere, the outer layer is corona, that is the atmosphere. So we are only concentrating on 3 layers: photosphere, chromosphere, and corona. These 3 are the outer layers of the sun. Clear?
Yes.
What is visible to us? What is visible to us is photosphere. That is called as the sun surface. That is the only thing what you see from your naked eyes. When you see from the naked eyes the sun, you will be seeing the photosphere of the sun. So what is the temperature of this photosphere? That will be around 6,000 degrees centigrade. See, the center is 15 crore degrees centigrade, but when it comes to the photosphere, it becomes 6,000 degrees centigrade. And this 6,000 degrees centigrade emits lights. That is called as the visible light. That visible light reaches the earth. So the time taken for the light to reach the earth is approximately 8 minutes.
Okay.
From the photosphere, when it touches you on the earth, it will take 8 minutes for you. Okay. So the only visible layer to you is photosphere. That's all. What you see from the naked eyes is only photosphere. And even if you see in the telescope, you will be seeing only the photosphere. That's all. Okay. The second layer, chromosphere, is also slightly visible, but the corona as a whole, the outer atmosphere, is not at all visible to you. It is not at all visible. It is visible only when there is a total eclipse. When a total eclipse happens, it may happen only twice a year. You will see a ring type, like they call it as aura. It is a ring type. That ring type will be a very feeble light, what you see.
Yeah, the outer shining part that we usually see.
Shining part, yes, the ring. That is called as the corona. So if you want to see corona from Earth, you have to wait for the total eclipse to happen. So this is what you can see the corona. Now we are clear. Now we are studying only 3 layers. That is the photosphere, chromosphere, and the corona. That's all we are studying.
Okay. So this Aditya L1 mission is going to study these 3 spheres in basic words, if I have to explain it. Oh, okay.
Yes. These are the 3 layers what Aditya L1 is going to study.
Oh, okay. And what could have been the challenges that Aditya L1 the whole mission must have faced to reach the orbit? And like you had mentioned that this perpendicular part, that is very important because they had chosen this very specifically.
I will show you that perpendicular part also. Just a minute. See, this is how the Earth is rotating. See, okay, this lines is there, no? That is the Earth rotation how the Earth is rotating. And the L1 I have shown this lines is there, no? That is the Earth rotation orbit. Is perpendicular to the rotation. And the L1 I have that is what I am just showing you how the halo orbit is perpendicular, not like an elliptical shape. It is somewhat that is what I am just showing you how the halo orbit looks, but it is not like an elliptical shape. Waves. It is somewhat horizontal, like one perpendicular. When you intersect some waves, shape will come. How it comes. It will be somewhat two waves. One horizontal, one perpendicular. When you intersect some shape will come. Aditya will be somewhat a very always keep maneuvering. They have some engines, so that is called as the lab Aditya L1, and they have got certain always keep maneuvering. They have got certain gyros. That is called as the lab engines, and they have got certain thrusters. They will be operating all such things from the ground station, where engines gyros will be sitting in the ground station. They will be operating all such things from the ground station, and there will be people will be sitting in the ground station in Bangalore or in Hassan or anything like that. And if they miss that maneuvering and it slightly shifts maneuvering, then you will lose the communication between the satellites. If they miss that maneuvering
the mission might fail.
It happened, then you will lose the communication between
running
the
there
satellite.
already.
Okay.
Two
Then the
satellites,
whole
wind,
mission
Soho.
might fail.
Already
It
the
happened for
Americans
Soho
have
one
launched the
satellite is
satellites,
running there
and
already.
America
Two
ESA
satellites
agency have
Wind,
launched the
Soho.
satellites.
Already
Soho
the
is working
Americans
from past
have
25
launched the
years.
satellites, and
So
America
it is
ESA
also
agency have
observing the
launched
sun.
the satellites.
So you
Soho
should
is
ensure
working
that
from
our
past
satellite
25
does not
years.
do any accidents
So
with
it
these
is
satellites.
also observing
So
the
such
sun.
maneuvering
So
they
you
will
should
keep
ensure
doing
that
around
our
the halo
satellite
orbit
does not do any
Okay.
accidents with
watching
these
the sun.
satellites. So such maneuvering
So,
they
sir,
will
can you
keep doing
explain
around
us
the halo
how
orbit.
this whole Aditya L1,
Keep watching the sun.
it reached? How did it reach the orbit? What was the process like? If you can tell us about that also. How did this mission take place?
Okay. See, Aditya L1 started. The concept was started way back in 2006 and 7. The people wanted to start studying sun. So astrophysicists, see, studying of the sun, everything is done by a team called astrophysicists. So they are the people who study what the planets are, what the planets generate, how Earth rotates. It is not ISRO. Okay, ISRO only gives the equipments and delivers such equipments to study and give the data to the astrophysicists to compile and get out the results. So a team of astrophysicists went and approached ISRO stating that they want to study the sun and effects, which is what sun effect, what is the effects of the sun on the earth. See, sunlight is so important. You agree for that, no?
Yeah.
Because for our living and for our everything, we need
Survival.
the sunlight.
It's a primary.
Yes, for our living, for our even your body needs vitamins, or your body needs vitamin D, B12, anything, or plant to grow, plant to photosynthesis. Everything sun is required. There are a lot of pros and there are also cons from the sunlight. So when the astrophysicist went and asked ISRO that they want to study the sun, ISRO came out with a concept. Okay, we will help you to study the sun. You give us one instrument like corona. We will start doing a coronagraph. You give us. We will send it to a low Earth orbit. Low Earth orbit means from you can say from 200 kilometers from the Earth's surface to 2000 kilometers. It is called as a low Earth orbit. So we will send we sent Exposat on January 1st. No, that has gone to low Earth orbit. That is around 800 kilometers. Now this what they told, we will send it to 400 or 600 kilometers, and from there we will start studying the sun. So the satellite weight was decided around 400 kgs. What they decided initially. Then when they went, they took the proposal to then chairman Professor U.R. Rao, means Udupi Ramachandra Rao. He is from Karnataka. So he told that no, nothing doing. Low Earth orbit, if you launch the satellite, there will be lot of disturbances. There will be lot of eclipse or some comets or something passes by, and there will be lot of disturbance. So we will not go for this. We will take it to L1.
Okay.
So you can start studying more. Why only coronagraph? Start studying photosphere, start studying chromosphere. So you develop these instruments for studying all these things. They told to the astrophysicists. So the astrophysicists, what they did, they developed 7 instruments to study the sun. So these instruments are all made indigenously. Out of these 7 instruments, 4 instruments are for remote sensing. Means they act like a high-end telescopes observing the sun. The 3 other instruments are in situ analysis. Means they will collect the particles which is coming out of the sun. There will be lot of emissions and particles which is coming out of the sun. They will analyze on the spot and give the results to the ground. That is what means the in situ analysis. Okay. So there are 7 instruments. Out of 7, 4 are remote sensing. 3 are in situ analysis. So they sent 7 instruments, and now the ISRO had an work coordinating with all the 7 instrument development which is happening across India. Each institute of astrophysics, they started developing on an instrument. They finally came out with the 7 instruments. ISRO had to coordinate, they had to cross-check it, they have to calibrate it, they have to bring it, see that whether it fits in the satellite. There were many works which happened, and it took at least 15 to 16 years for the complete project to get matured. So many years took place. So initially it was Aditya 1, which was about to launch to low Earth orbit with 400 kg. Finally, it became Aditya L1 because of Professor U.R. Rao. We should remember him today. And the satellite weight went to 1,450 kgs, out of which around 230 or 240 kgs is only the payloads, the 7 instruments. The rest is the satellite body along with fuel. So 1,450 kgs of the satellite along with the 7 payloads has reached the Lagrange L1 point. Now I'll tell you the instruments. What are the instruments which has gone, the 7 instruments, and what each instrument will do, so that we can understand why Aditya L1 has been sent. See, the project they have planned is for 5.2 years. Approximately. This mission is 5.2 years. The project cost is 400 crores. I think I have told you in the beginning itself. So the mission is for 5.2 years. So first instrument I will go is the VELC. This is the primary payload. This is the primary payload. This was developed by the Indian Institute of Astrophysics, which is in Hosakote, Bangalore. This was developed there itself, and it gives approximately 1,440 to 1,450 images per day to the Earth. Okay. And what it does is it only studies the sun corona, means the outer surface. Means when the instrument blocks it blocks the photosphere, chromosphere, everything, and it only concentrates on the sun's corona. On the outside atmosphere.
Yeah, we remember the shining.
See, I will tell you how big is sun corona. I will tell you. See, photosphere is just 500 kilometers. I'll just share this one. Photosphere is just 500 kilometers. Okay, and after that comes the chromosphere, which is 2,000 to 3,000 kilometers. Okay. And after that comes the chromosphere, which is temperature at 2,000 to 3,000 degrees centigrade, where the light is coming down to the Earth from the photosphere, and that is called as the sun degrees centigrade. Where the light is sun surface down to the Earth, should know it is only photosphere, and that is called as the sun surface. Then comes the chromosphere, where the sun surface again increases, know it is only to 20,000 degrees centigrade. Then comes the chromosphere, where its distance is between 2,000 to 3,000 kilometers, 20,000 degrees centigrade. After that comes corona. Its distance is between 2,000 to 3,000 kilometers distance. After that, millions of kilometers distance. So corona and sun means surface means it kilometers. Not like Earth. It is not sun. Is not millions of kilometers distance. It is a and sun means surface means it. You can say not like Earth. It is not. So not like the corona, the outermost, it extends to millions of kilometers. Okay, but the temperature, the corona, the outermost, it extends to millions of kilometers. Says it goes to temperature there to 40 lakh so high degree centigrade. What you can say is it goes to at least 40 lakh to 40 lakh 6,000 degrees centigrade. Degree centigrade nearer to the center. But the outside corona, see, photosphere is 6,000 degrees centigrade, which is nearer to the center. Why this? But the outside corona, why such 30 lakh degree centigrade? Why this? That is one challenging to the scientists. Why such difference? Each one is coming out with each view. So that is
that
one
why the
challenging to the
temperature at
scientists.
outside is
They
so
are
high than
each
compared to the
one is coming out with each
photosphere, which is
that why the temperature at outside is so high
than
really the
compared
heat
to
is
the
getting generated.
photosphere,
So
which
the
is
one challenge where the VELC is going to study is why this corona is
so high
so
in
the one
temperature
challenge
compared to the
photo
photosphere.
Yeah,
VELC
so we
is
might
what is the
find
dynamics
some
of why this
answer
corona
from
is
that.
so high
Yeah.
in temperature compared
So
to
we
the
might find
photosphere.
some answer
Yeah.
from
Hello,
the
what is the
hello,
dynamics
some
of heat
answer
transfer?
from that.
Can you hear Hello, me? Yes, yes.
Yeah, so we might
Yeah,
find
yeah.
some
So we might
answers
find
from
some
the
answers
first
from the
instrument
Hello?
about why
Yes,
there is
Can
such
you
a
hear me? Yes,
huge
yes.
difference
Yeah,
in
so we
sun
might
surface
find some
itself.
answers
From the first instrument about
Yeah,
why
that
there
is
is
sun
such
surface
a
and the
huge
corona.
difference in
Why
sun
there is so
surface
much of
itself.
difference?
Okay.
Why there is so much of difference? Sun surface and
means
corona.
photosphere.
Yeah,
Why there is
yeah.
to be very clear. So
Yeah.
why from sun
Okay.
surface
Why
to
there is
corona?
so much of
There
difference?
is from sun surface
so
means
much of
photosphere.
heat difference.
It
Yeah.
should be very clear. Okay, that is
So
the
why
first
from
thing.
sun
Yeah.
surface
But you can
to
ask
corona,
Soho, which
there
is there
is
already
so
of
much of
American
heat difference.
and ESA satellite.
Okay,
that is the first thing.
And 25
But you
years
can
back,
ask Soho,
it lost
which is there
its
already
coronagraph.
of American
The
and
coronagraph
ESA
got
satellite
damaged.
damaged. And it could
years
not
back,
read the
it lost
coronagraph.
its coronagraph.
The corona.
Oh.
So
The coronagraph
you can
got
say we are
damaged.
the first
And it
Indians
could not
to read the coronagraph by launching this
Oh.
the corona.
Aditya.
So you can say we
So
are
there
the
is going to be
first
another
Indians to
accomplishment
read the
added to
coronagraph by launching
Aditya
this
L1.
Aditya
L1.
yes.
Okay.
L1.
So there is
So
going to be
this is a
another
very big,
accomplishment added to
accomplishment you can say
Aditya
that
L1.
yes, what has been developed. So this is a very big
by the
accomplishment
Indian Institute of
Astrophysics, which is in
PLC,
Bangalore.
what has been
So
developed,
they have developed
by
they have
the
got many
Indian Institute
mirrors,
of Astrophysics,
each
which
mirrors
is
they
in
have polished to somewhere.
so
They have developed.
accuracy, I cannot say
They
that
have got many mirrors.
they call it
Each
GM
mirrors they have
accuracy.
polished to somewhere.
So it
high
is the polish
accuracy, I
itself. They
cannot
have
say
taken
that,
years to do the mirror
they call it
polishing
GM
and such
accuracy.
things.
So now
it is the polish itself.
I
They
am
have taken
explaining you
years
the
to do the
VELC.
mirror
Now I
polishing
explained
and
you
such
about the
things.
temperature variation.
So
between
now,
the sun surface, that is the
I am
photosphere,
explaining you the
and
VELC. Now I explained you
outer
about the temperature variation
atmosphere
between
of
the
the
sun
surface,
surface,
that is the
corona.
photosphere.
It is going to
And
around
the
30 to 40 lakhs
outer
degree centigrade
atmosphere
temperature.
of the sun, that is the
And
corona.
in the photosphere,
It is going to
6,000
around
degrees
30 to
centigrade.
40 lakhs.
But
degree,
one thing I want to tell
centigrade
you,
temperature,
though the heat is very
and
high
in the
in the
photosphere,
corona,
it is 6,000
the
degrees centigrade.
light emission
But
is
one
not
thing I want
very
to tell
strong.
you, though the heat
The light
is
is
very
very
high in the
weak.
corona, you cannot
The
see
light
the light emission is not
which
very
strong.
comes from corona.
The light
So-
is very
so
weak.
It has got a
You
very
cannot see
intense
the light,
heat, but the light
which,
rays
comes
are
from
very
corona.
low.
So very
So
dim.
it has
So
got
it can
a
be
very
only
intense
seen
heat,
during
but
the
the light
total eclipse.
rays are
So
very
what this
low,
VLC
very
does
dim.
is,
So
it
can
has
be
got
only
four
seen
other
during the
instruments
total
embedded in the
eclipse.
VLC.
So what this VLC does
Along with
is, it
studying
has
the
got
heat
four
variations,
other instruments
embedded
embedded
in the
it has got four instruments to do so.
along with studying the
See,
heat variations.
one more thing in the corona
means
it has got four
it generates
instruments
a
to do
violent
energy. See, one more thing in the
what I can
corona
say is
what it happens
violent
it generates a violent
ejection of energetic particles.
what I can say
That
is
is called as plasma.
violent
Plasma means
it is the
ejection
fourth
of
state
energetic
matter.
particles.
One is the
That
solid,
is called as
liquid,
plasma.
gas.
Plasma
The
means
other one is called
it is
as
the
fourth
plasma
state
state
of matter.
where the
One is the
gas,
solid,
where the
liquid,
atoms inside the gas.
The other
get
one is
ionized.
called as the plasma
Due to
state,
the heat, it
where
gets
the
split
gas,
into the
where the
electrons and
atoms
photons.
inside the gas
Okay,
get ionized.
these things
That
due to the heat, it
violently
gets split
ejecting
into
the
the
plasma
electrons and photons.
keeps coming very
Okay,
fast to the ground.
these things
that
actually
violently
to
ejecting
what
the
the
plasma
speed it comes, I can say,
keeps
is
coming
around
very fast to the
3,000
ground.
kilometers per second. The
Actually,
speed it
to
comes.
what
This,
speed
violent
it comes,
particles,
I can say is
energetic
around
particles.
3,000
So it
kilometers
takes
per second. The
approximately
speed
15 hours to
this,
reach
violent particles.
energetic
Even
particles.
at that speed,
So it takes
approximately
15 hours
15 hours
to
to
reach
reach
speed.
the. There will be one is the ejection
Even at
of
that speed,
energetic
it
particles.
takes
Then
15
the
hours
other
to
one is
reach
the coronal mass
speed.
ejection. There will be one
Coronal
is
mass
the
ejection
ejection
means
of
it actually
energetic
it
particles.
spits
Then
out the
the other
mass
one is the
means
coronal mass
there
ejection.
will be lot of
Coronal
particles.
mass ejection means it
Energy
actually
mass
spits
spits
out
out
the
the
mass.
there will be lot
means
of there will be lot of
what you can say,
particles.
there is lot of radiation,
Energy, mass of
rays,
the
lot
sun,
of
there will be lot of
particles,
lot of rays.
what you can
All
say,
this
there is
will be
lot of radiation
spitted out from
infrared
the
rays, lot of
this is called as the coronal
particles,
mass ejection.
lot of rays.
So all this will be
how to study
spitted
this?
out
Why
from
sun is
the
behaving
this
so
is called as the
violently?
coronal
Why it
mass
is spitting
ejection.
out so much
So,
of energetic
how to
particles?
study this?
Then
Why
the
sun
coronal
is
mass
behaving so
ejections.
violently?
And
Why
what
it
will
is
happen
spitting
to us?
out so much
So
of
it is
energetic
happening for many
particles
years.
than
And what
the
is going to
coronal
happen?
mass ejections.
See,
And
when
what will
these
happen
things
to us?
comes out,
So
no, it is
we have
it is
many
happening for
space
many years.
assets.
And what is going to happen?
We have many
See,
satellites.
when these things
India
comes
itself has
out,
more
no,
than 50
we
to
have
100
many
satellites.
space
More than
assets.
50,000 crore of
We have many
satellites.
India
On,
itself has
about
more
the
than
space,
50 to
Indian
100
satellites.
satellites.
I'm telling,
More
not
than
the world
50,000 crore of
So,
satellites.
so many satellites are
on
moving
above
the
the
space.
when
Indian
these
satellites, I'm telling,
particles
not
come
the
and
world
hit the satellite.
so many
What
satellites are
happens? The
moving.
satellite gets
So,
damaged. When these particles come
Or
and hit
when
the
these,
satellite, what I said,
what
that,
happens? The satellite get damaged.
energetic particles, that is the
Or
electrons.
when
and all,
these,
when it comes and hit the
what I
Earth
said,
magnetic field, there will be a
energetic
disturbance
particles,
in the
that is
Earth
the
electrons and all. When
geomagnetic
it comes
field.
and hit the Earth
What happens when
magnetic
there is a
field?
disturbance in
There
the
will be a
geomagnetic
disturbance
field
in
of
the
the Earth
because of
this
magnetic
particles coming
What
from
happens
the
when
sun
there
and
is a
the Earth
disturbance in the
magnetic field when they
geomagnetic
collide
field of
each
the
other?
Earth? Because
Then
of
there
this,
will be lot of variation
particles
in
coming
high
from the
power
sun
line,
and the Earth
your
magnetic
electricity,
field when they
your
collide each
radio,
other.
your
Then there will be
transmission,
lot of variation in
everything
your
get
high
disturbed.
power line, your
It
electricity,
has happened
your
in Quebec
radio,
in Canada
your
where 9 hours
transmission,
power was not there at all
everything get
for them.
disturbed. That was
It has
because
happened in
of this
Quebec
solar
in Canada where
problem
9
of the
hours
solar
power was
storm.
not
It
there
can
at all
happen more
for them.
to
That was
Bangalore also. It
because
can
of
happen
this
to
solar
anywhere also. We don't know
problem
when
of
the
the
solar
solar
storm
storm.
is going
It can
to hit
happen
and when
more
it can
to
do such
Bangalore
disturbances.
also. It can happen
So
to anywhere also. We
DLC
don't know when the
will
solar
help us
storm is
to
going to hit
give
and
you
when it
more
can
do
data
such
by
disturbances.
studying this
So
corona, when this is
DLC
likely to
will
happen.
help us to
Yeah, like it will
give
help
you
us
more
predict or
data
at least find
by
out
studying
something
this
more about
corona
it as
when this
compared to
is
what we
likely
used
more,
to
and
happen.
it can give you
Yeah,
at
like
least
it will help
because
us
it takes
predict
15 hours to
or
reach
at
Earth,
least find
no?
out
So
something
it can
more
give
about
you
it as
at
compared to
least
what we
more, and
in the
it can
morning.
give you at
30
least
hours
because
ahead.
it takes 15 hours to
Ahead
reach Earth, no?
or
So it can
half an
give
hour,
you
1 hour
at
ahead
least
of what
From
is going
morning.
to happen.
30
So
hours
be ready
ahead.
with it.
Ahead or
Right.
so that is
Or
how the
half an hour,
VLC
1 hour
instrument is
ahead
going to act.
of what is
It has
going to
got
happen.
four
So be
instruments.
ready with it. I told you. So what
Right.
it
So
does,
that is how the
four
VLC
instrument
instrument is
it,
going to act. It has got four
it
instruments.
studies
I
the
told you.
each
So what
light
it does that
it
four
keeps studying.
instrument is it
Like it studies the white light, it studies the red light, it studies
each light it keeps studying. What you
like
say?
it studies
The
the white
green
light,
light,
it studies the
and
red
it
light,
also
it
studies
studies
the
it analyze, it splits the light, that is called
what
as
you
the
say?
spectrometer.
The
It
green
splits the
light,
light,
and
it
it
studies
also
the
studies
orientation
it
of the
analyze,
light,
it splits the
and
light,
and
that
by
is called as the
doing such
spectrometer.
studies,
It splits
it
the
can
light,
analyze
it studies
what is
the
happening in the
orientation
corona.
of the light.
Mhm.
And when the
and by
corona,
doing
what changes
such
is
studies,
happening,
it can
and
analyze
what is
happening in the
coronal mass ejections
and
can happen.
when the corona, what changes is happening.
So this is
And
the
when this
one study of
Yeah.
DELC.
coronal
So
mass ejection
this is
can happen.
how important is DELC.
The
So this
next
is
one,
the
what I am
one
going to
study
come
of
is
Yeah.
the suit. So this is how this is also one another
The next
important
one, what
instrument
I am
what I
going to
would
come
like
is
to the suit.
Mhm.
SUIT.
the next
This is
instrument.
also
What
one
I am going to
another
talk is
important
about the
instrument
suit.
what I would
So
like to these two tell are you.
the
primary
The next instrument what I am
people
going
should
to
know
talk
why
is
Aditya
about the suit.
Yeah.
So
The
these
other
two are the
instruments,
primary
yes,
instruments
we
where
have to
every
just
people should know why
know what
Aditya
exactly
is
they are doing, but
saying.
not to the depth
The other
of
instruments,
these two
yes,
instruments.
Yeah.
we have to just
These were
know what
already
exactly they are doing, but
activated
not to
for
the
your
depth of
information while
these
it was
two
going
Yeah.
towards
it is
the Lagrange point.
These were
These
already
four instruments have
activated
already
for
got
your information
activated.
while it was
The
going
only the
towards
three
the in situ
Lagrange
this
point,
getting
these
calibrated,
four
and that
instruments
also
have
will get
already got
activated.
activated.
So the suit means
Only
it
the
is nothing
three
but
in
solar
situ this getting
ultraviolet
calibrated,
imaging
and that
telescope.
also will get activated.
That was
So the
developed
suit
by
means it is nothing but University
Solar
Center for
Ultraviolet
Astronomy
Image
and
Telescope.
Astrophysics, Pune.
Okay.
That was developed by
Okay, this
University
suit
Center
instrument.
for Astronomy
What
and
this suit
Astrophysics,
studies
Pune.
is ultraviolet. The word
Okay.
itself study
Yeah.
tells
This
the
suit
ultraviolet.
instrument.
Yeah.
See, there
Yeah.
is lot
What
of
this suit studies is
ultraviolet ultraviolet
ultraviolet,
photosphere
the word
and
itself
study tells the ultraviolet.
These
Yeah.
ultraviolet
See, there is lot
rays
of
does not reaches the earth
ultraviolet generation
because we have a ozone
Hmm.
layer.
Yeah, it protects
These
us.
ultraviolet rays,
You know that
does not
ozone
reach
is
us
getting
the earth
depleted because
because
Yeah.
we
gas
have a
emissions,
ozone layer.
in gas.
Yeah, it protects us.
everything
Global
to have.
warming.
You
Yeah.
know that
Yes.
ozone is getting depleted because
Yeah,
of
this
Yeah.
gas
ultraviolet
emissions,
rays
in gas
is emitted from the
Global
photosphere
warming.
and
Yeah.
chromosphere
Yes.
mainly. Yeah.
So
This
what this suit
ultraviolet
does
rays
it
is
starts
emitted from this
study- it will
photosphere
study
and
the
chromosphere mainly.
ultraviolet rays.
So what this suit
So
does is,
what
it
is the
starts
ultraviolet rays?
study,
Why
it will
we
study
cannot
the
from the earth
ultraviolet
because one
rays.
thing is ultraviolet rays does
So
not reach the earth.
what is
But
the
now
ultraviolet
some or
rays?
something
Why we
leaking
cannot
is
study
happening,
from
but
the earth
that
is
is not
because
enough.
one
to,
thing is ultraviolet
study
rays
that.
does not reach
This
the earth. But
ultraviolet
now
rays
some or something leaking
of
is
the
happening,
wavelength
but that
300
is
to
not enough
400
to
nanometers.
study that.
This ultraviolet
This
rays
is not
are
visible
of
by
the
the
wavelength
naked eye.
300 to 400 nanometers.
The visible light, what we can see in the
This
naked
is not
eyes,
visible
is between
400
400
to
to
700 nanometers.
The visible light, what
So
we can see in the
what
naked
this
eyes, is
suit
between
does is
400 to
it
700.
starts
nanometers.
reading the ultraviolet rays.
That is
So
very near to
what
the
this
violet rays.
suit does is
Violet rays
it,
is what is
it
visible
starts
to you.
reading the
Yeah.
So it is
ultraviolet rays.
that is
it
very
a
near
400
to the
newton
violet
meters,
rays.
means it is the
Violet
beginning
rays
of
is
seeing.
what is visible
So you
to
cannot see as
Yeah.
So
violet.
it is
you
a
see as a purple
it is a
usually.
it is a
Yeah.
400
So
newton meters.
that
Means it is the
r-
beginning of
rays,
seeing.
it starts
So you
studying.
cannot see
Suit
as
will
violet.
start
You
studying
see as
about the
purple
ultraviolet
usually.
rays.
Yeah.
So
And it will study
that
the dynamics of the
rays, it starts studying.
photosphere
The
and
suit
the
will start
chromosphere.
studying
Hmm.
about the ultraviolet
See,
rays.
in
And it
photosphere,
will
there are
study
some
the dynamics of the
sunspots. Photosphere and
due to
the
some sudden
chromosphere.
change in
Hmm.
the magnetic field.
See, in
Magnetic
photosphere,
field
there are
will be
some
twisted.
sunspots.
So when it
Due to some sudden
tries
change in
to
the
get
magnetic
straight, like
field,
rubber band, when you
magnetic
touch and
field
you-
will
when
be
you leave
twisted.
it now,
There will be some
so when
energy coming out.
Yeah.
tries to
That
get
is called
straight, like rubber band,
as
when
the
you touch and
sunspots.
when you leave
Because
it
of
now,
that energy,
there
there
will
are
be
a lot
some
of
energy
sunspots coming out.
Yeah.
That is called on the photosphere.
as the sunspot.
These sunspots,
Because of that
also
energy, there are a lot of
creates
sunspots happening
what
there
is called as the sun
on the
flares.
photosphere.
Okay.
These sunspots also
And these
creates,
sun flares are
what is
nothing but
called as the
again
sun flares.
energetic radiations,
And
also
these
the
sun
movement of
flares
the
are nothing but again
that is
uh,
called as
these
energetic
particles get
radiations
more of
and
momentum
also
because of
movement
the
particles.
high temperature of the
That
gaseous
is called as
around corona.
sun,
These
yeah.
particles
start
get
moving
more of
towards the
momentum
earth and
because
again
of the
start
high
disturbing our
temperature of the
satellites and
gaseous
systems.
around corona.
So by
Yeah.
studying
These
this
start moving
ultraviolet
towards
rays,
the
they
earth
can
and again
study when
start
there will
disturbing
be an
our
appearance
satellites
of the
and
sunspot.
things.
This
So
sunspot
by
may be
studying
for
this
weeks or months
ultraviolet rays,
together.
they can
So when
study
these
when there will
sunspots
be
will
an
get
appearance
disappeared.
of the sunspot.
So these
This
sunspot
sunspot may
dark
be for
spots,
weeks or months together.
which has got
So
a
when
very high
these
intense
sunspots will
magnetic
get
field.
disappeared.
Hmm.
So these sunspots are some
Okay.
dark
So
spots.
Yeah.
Because of that, there is
which
lot
has
of
got a very high
radiations and other
intense magnetic
rays
field.
coming out of that, other radiations,
Okay.
gamma rays.
So
Yeah.
Because of
Hmm.
that, there is
coming out
lot of
which can disturb
radiations and other rays
satellites,
coming out of
communication
that,
system and
other
such things.
radiations,
So
gamma
suit
rays,
is there
such
to
things
Hmm.
are coming out which can
this
disturb
type of
photosphere and
satellites,
atmosphere by
communication system and
observing
such
the
things. So
ultraviolet
suit
rays.
is there
Yeah.
to
So
study
I have
this
told you very type of
Yeah.
photosphere
very
and
simple manner.
chromosphere by observing
The
the
third one is
ultraviolet rays.
solar.
So
Yeah.
I have told you very X-rays.
Yeah.
That is very
Yeah.
it's also one type of it is a very
Okay.
short
The
X-ray.
third
It's
one
not
is
what we do.
solar.
Yeah, the doctor
Artificial X-ray. What is generated? Type of it is a very short X-ray. Means not what we
0.01 to
do
10 Newton
it
meters.
in
Yeah, the doctor
artificial X-ray. What is generated?
Visible.
It is
0.01
about
to
0.01 to 10 Newton
not
meters.
at all visible to us.
See,
So
400
it
to
studies
700
X-rays
so this
visible.
also helps us to study
0.01 to
what
10
is solar
Newton
flare
meters,
and
not
at
at
all
visible to us.
surface of
So
the
it
sun
studies
and such things.
X-rays. So
So
this
it
Yeah,
also
it
helps
gives
helps
us
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 more
to study
knowledge
what
about
is solar
it.
flare and
Yeah.
surface
X-rays.
of the sun
Then
and
comes
such
the
things. So
fourth
it
Like,
one
it gives
is
us more knowledge
that
about
is called as eye
Right.
energy
X-rays.
orbiting X-ray
Then comes
spectrometer. That is
the
called as
fourth one is
HEL
one
that is called
OS,
as
means
eye
that
energy
studies the
orbiting
X-ray,
which is little bit
spectrometer,
strong,
that
which is
called
from
as,
10 to 15
HEL
kilo
one
electron
OS,
volts. Means that studies
got a
the
little bit
X-ray
high
which is
energy
little bit
compared to
strong,
what,
which is from 10 to 15
Solex
kilo
does.
electron
So
volts.
they
They study that
which
X-ray.
has got a little bit
Then
high energy
it's in
compared to
situ
what,
analysis. One
this
is aspects,
Solex
the
does.
other one is
So they study
what
that
is called
X-ray.
as the
Then
solar
it's
wind
in situ analysis.
One is aspects, the other one is
in Solex
what is
there are
called as
Swiss and
the
steps.
solar wind,
And then comes the plasma
Swiss.
analyzer
The other
package
one
that
is
is
called as
Papa.
in Solex.
And there are Swiss
Then
and
comes the
steps.
magnetometer.
And
So
then comes
these
the
things things
plasma
are the
analyzer
digital
package that is
which
called
does
as
lot of in
plasma,
situ
and
analysis.
then
So the
comes the
major thing
magnetometer.
what we have to
So
understand
these
is
things
what
are
the
the
digital
DLC does, and
magnetometer
which
which
does
does lot of
so
in situ
it
analysis.
understands why we
So the major thing what we have to
The main
understand is
mission, the
what
main idea
VLC
is
does and
from
Shoot
VLC
does.
and
So
Shoot
it
that we are
understands why
getting.
we have sent the Aditya. Of course, other
The
things are
main
important,
important, the
but
main idea is
people
from
to
VLC
understand
and
these
Shoot
two things
that we are getting.
are the
gives
main
us
a very, of course, other things
main
are
idea
important,
for
but
what Aditya.
people to
yeah.
understand.
Also,
These
sir,
two
you
things
mentioned
are
that
gives us a
this
very
the mission to
main
study
idea
the
about
sun
what
had
Aditya.
started way back in
Also, sir,
2005.
you mentioned that
started
this working on
the
it.
mission to
But why
study
did
the
India
sun
take so long
had started
to,
way back in
send its
2005.
first solar
Astrophysics
mission?
had started
Why does it take so
working
long?
on it. But why did India take so long
See,
to,
I can say that there was
send
a
its
push after
first solar
Chandrayaan 1.
mission?
A
Why
real
does
push
it take so
happened when they
long?
sent the probe. To
See, I can
study
say
the
that
mission
there was a
somewhere
push
in
after
that
Chandrayaan
time
1.
itself.
A
A
real
real push happened
So
when they
that
sent the
probe, and after that they
to
sent
study
the
the mission somewhere
Mars
in
orbiter.
that time
The
itself.
Mangalyaan
I think
mission,
so.
one
mission
Hmm.
MOM,
So that
Mars orbiter
probe, and
Yeah.
after that they
So
sent the
then they
Mars
were
orbiter,
very
that is
clear.
the
Means
Mangalyaan
orbiter
mission, one
means
mission
orbit,
MOM,
Yeah.
Mars
or
orbiter
anything
Yeah.
means
it is like a telescope observing.
then they
Hmm.
were
Okay,
very
which
Yeah,
clear.
like you
It does not
mentioned in the
really
beginning.
go and sit on.
or
It
anything.
really does
It
not
is
go
like a
and sit
telescope
on Mars
observing.
surface and
Hmm.
does the
Okay,
study.
which
Yeah, like
It
you
does
mentioned
not
in the
really
beginning.
go and sit on.
Right.
It really does not go and sit on
we
Mars
got
surface
more
and
of
does the study.
confidence
It
about
observes some
developing
certain
such
distance.
things.
So
Then
it was
we got more of
little momentum
confidence
for
about developing
hastening the
course,
project.
yeah.
And of
So
course, the
then
7
it was
instruments which has to be
we
developed
got
by
little
the
momentum
various
for
astrophysics
hastening the
across
project.
India.
And of course,
So
they have
7
to
instruments which has to
coordinate,
be
they have
developed by
to
the
calibrate,
various
they have to
so many things
to
get
across
the things
India.
right.
So they have to coordinate, they have
fitted
to
on the spacecraft,
calibrate, they have
all
to
these
do
things.
so
So
many
it has
things
taken many
to get
years,
the
of
things
course. Right.
and more machines
Fitted on
were
the
there
spacecraft,
Hmm.
all these things. So it has taken many
of
years.
course, there will be a different team to work for each
And
project.
more
All
machines
project, all
were there. It
will
not
Yeah.
work only for
Yeah.
this
But
or that.
of
Or
course,
there are
there will be a
different
different
project
team to work
teams
for
in it.
each project.
So
All
this is
project,
what
all
has
scientists will not
Yeah.
work only
taken
for
time.
Yeah.
This
Okay.
or that. Or
Also,
there
sir,
are
can
different
you
project teams
tell
in
us
it.
what
this
could be
is
the
what
future
has,
challenges for this? Because it's
taken
going to
time.
sit there
Okay.
for over 5
Also, sir, can
years.
you
Like at
tell
least
us
initially, that's the
what could be
approximate
the
that
future
ISRO
challenges
has
for this?
mentioned.
Because it's going
So
to
what
sit there
can
for
be the
over 5
challenges that
years.
can
Like
come across?
at least
At
initially,
this
that's the
time.
approximate that ISRO has
The
mentioned.
maneuvering
So
is a
what
challenge.
can be the
Maintaining in the
challenges
same
that can
orbit
come
is a
across
challenge.
over this
Always
time?
establishing from the maneuvering
space,
is a challenge.
of course,
Maintaining in the
Space
same
Agency
orbit
is
is
a
helping
challenge.
us to get the data.
Always
From the deep
establishing
space
from the
means
deep
what
space.
Aditya
Of course,
L1
the
it has
European
to reach
Space
1.5
Agency
million
helping us
kilometers
to get the data.
So you need
from the
special
deep
types
space
of
means
softwares and
what
such things
Aditya
to get the
L1 it has
data,
to reach
retrieve the
1.5
data,
million kilometers.
and
you
so
have
you
to
need
get the
special
real-time
types of
data,
softwares
means,
and such things to get the data,
it happens
retrieve the
and
data,
by the time it
and
reaches you, it
you
takes
have to
20
get the
seconds, 30
real-time
seconds
data,
or
1
minute
minute
or
or 8 minutes. Then so many things
it
would have
happens
changed
and
before you
by the
read the
time it
data.
reaches
Yeah.
you, it
Getting
takes
the
20
real
seconds,
time
30
data.
seconds or 1
So
minute or 8 minutes.
maneuvering,
Then so many things
getting
would
the
have
real
changed
time
before
data.
you
Of
read the
course,
data.
Yeah.
instrument
Getting the real time
is also a challenge.
So
We don't know
maneuvering,
like
some
getting the
chronograph
real
itself
time
got
data.
spoiled.
Of course, we do not know.
may is
So
also a challenge.
calibrating,
We don't know, like
maintaining the
some
instrument in
chronograph
the
itself
right
got
way,
spoiled.
seeing that the
We do
results
not
are always
know
so
accurate what we are
calibrating.
getting. There are many
maintaining
challenges
the
which each
instrument
day
in the
each
right way,
scientist has to
seeing
thrive
that the
upon to
results
see
are
that
always
accurate
machine
what
is
we are getting.
functioning.
There are
very
many
perfectly.
challenges which each day
And
each
also, so
scientist has to thrive
when
upon
if
to
this
see
mission
that
is successful completely
machine
after
is
5 years,
functioning
you've
very
already
perfectly.
mentioned that the data points
And also,
that
so
India can collect
when if this mission
through
is successful
this whole
completely
Aditya
after
mission,
5 years,
you've
what
already
would that
mentioned
mean
that
at the
the
world
data
stage
points
for
that
us?
India can
Like
collect
the success of this
through
mission,
this whole
what would
Aditya 1 mission
represent India, and how
what
is it
would
going
that
to help
mean at the
the
world
Indian
stage for
space
us
like
research to
the
grow?
success of this mission, what would
See, anything you do
represent
on
India, and
space
how is it going to
research,
help
it
the
is
Indian space
helpful to the
research to
mankind.
grow?
It is not helpful to a country. See, anything you do on
whether
space
NASA does,
research,
ESA does,
it
or
is
anybody.
helpful
See,
to the
without
mankind.
ESA's
It
help,
is
we are
not
not getting
helpful
deep
to a
space
country.
Knowledge.
whether
Communication.
NASA does, ESA does,
Of
or
course,
anybody.
NASA also
See,
will
without
be
ESA's
tracking
help,
this,
we are
also
not
will be
getting deep
tracking.
space.
Of course, the data is
Knowledge.
collected
Communication.
differently. And they
Of
share
course,
the
NASA
data. That
also
is
how
how
the
the
space
space
ESA
as
also will be
community
tracking
works. It cannot happen collected will be only one country, and they share only such things can happen only with the spy community works. It cannot happen with the spy satellites or military satellites. Only such things can happen only with the spy satellites country, but not these type of satellites or military satellites that will be all the agencies get involved and all the people, but not these type of study the data, which is and it will be shared all the agencies get involved and all the each and everybody, even NASA to study the data, and it will be shared across the Japanese. So that it helps each. In fact, the Indian Space Agency is now talking in terms. We have reached to a level. In fact, the Indian Space Agency is now, of course, Chinese talking in terms. We have reached to a level. So we have reached to that level where Japan itself has approached Chinese to give a lander. They are launching on.
Yeah.
So we have reached to that level where Japan itself has approached us to give a lander. With NASA collaboration, we are launching one more missile. So we are next with NASA collaboration. So that is the study of the Earth one more missile. It may happen. And we are sending one more satellite for the communication. So that is the study of the Earth broadband communications like Lakshadweep. And we are sending one more satellite for the communication. Andaman and Nicobar, where there is no much of like Lakshadweep, where Modi went. So we are Lakshadweep and Andaman January 10th, where there is that is the GSAT N2 or something. So we are launching that. That we are using American spacecraft. That is SpaceX GSAT Falcon 9 or something. Because we are launching the weight that we are using American spacecraft because our SpaceX that is Falcon 9. So because it is so we are taking more than Falcon 9. So these are the things. Lot of collaboration and many private players. So we are taking many countries are coming and asking. So these are the things. Lot of collaborations are. We have launched so many private players are coming. Many countries are coming and asking our help to launch once, and we created a. We have launched so many satellites in 2023. We launched 104 satellites once, and
So this
we created
also
a world
adds
record.
to that, like the whole collaboration
India is
and the Aditya
globally
1
growing
mission.
very fast in
The
space.
information
So
that
this
we get
also
is going to,
adds
of
to
course,
that,
like the whole
world, if I
collaboration
put it in a
and the
just-
Aditya 1 mission. The
Definitely,
information that we get
definitely. I'm
is
telling
going to,
you
of
the
course,
study
help the
of
whole
coronagraphy,
world, if I put
the
it in a
detailed
just.
study what we are doing. We can say we are definitely the world. Definitely, I'm telling you the study of coronagraphy. The detailed study what we are doing, that is very important in the world. Corona mass ejections and violent energy particles coming out. And all these things are very that is very important to safeguard corona mass ejections, safeguard violent energy particles coming out. Safeguard our things are very what is the radiation, safeguard our assets, safeguard our communication. All these is very important. Safeguard our what is the radiation.
Thank you
what
so
is
much,
coming
sir,
out
for
the,
this explanation. I think we
persons. All
got
these
the
is very
overall
important.
mission also, and we understood a
Right.
more the
Thank
sun
you
in
so
more
much, sir,
depth
for
about
this
its part.
explanation.
And
I think
what
we
got the
exactly is
overall
Aditya
mission
L1
also, and we
meant
understood a
Thank
more
you so much
the
for
sun in
taking
more
out your
depth
time
about
and
its sharing
part
this
and what
information
exactly
with
is
us.
Aditya L1 meant for. So thank you so much
Thank you
for
very much.
taking out
Thank
your
you
time and
for
sharing
inviting
this
me and
information with us.
giving me time to talk about this subject. Maybe we can go in depth in the coming. Of course, we will conduct more such programs and see that how we can help people to understand why such machines are happening, why such machines are required, and also develop that inquisitiveness among our young children, why they have to study about space, what is space, why is it important. All these things we can keep on
Yeah.
doing in the coming.